Hello, this is James. I'm going to walk you through what we've done in Hardware Labs 3, 4, and 5. You can see my screen here. I'm actually running synthesis currently on Lab 5. So in Lab 3 you only have the zinc, you don't have the other components that are shown in here. So in Lab 3 we open this, double click it, recustomize IP, and we're going to add a bunch of peripherals which will then export over to the SDK. Okay, so at the end of Lab 3, or at the end of Lab 2, we didn't have GPIO, USB, we didn't have any of these checked. All that we had was UART1. So in this lab, we come in and we go through and we manually are adding this. And again, this training seems really geared towards if you are an embedded engineer, you're going to do a custom board layout, you're going to wire things in manually exactly how you need. So you're not necessarily using the Ultra 96. I think there'd be easier ways to get the Ultra 96 set up. So this SD is the actual SD, the physical SD card, and it's using these particular multiplexed I/O pins. And of course, there's other ways that it could be wired in. And this has the card detect on MAO24. Now I've got SD1, which is the Wi-Fi chip. In the way that this is set up, this is how it comes in on these pins. Okay, I2C. So we've got this one right here. We've got the power management unit on GPIO, GPI0, excuse me. SPI, we've got set up on here using these pins. Slave select 0, slave select 1. Another SPI. Here's the UART, which we've now added an additional one. This one is for the Bluetooth radio, and this one is the more physical UART. Okay, and so on. Triple time counters. So we've come through and manually add all of this stuff. I won't go into all of those. A bunch of things on the clock configuration that we had to do. Output clocks, changing frequencies, changing the source clocks to IO PLL for a lot of things, phase lock loop. So I'll just cancel out of this. So then after that was done, we exported it over to the SDK, which I'll show you here in a sec. Okay, here we are over in the SDK, and we can see the hello world that we made earlier on, and then we made a new program from new application project, and you choose memory test, and then we just go ahead and run this. I did have one issue where I go to run this and it was actually running my hello world, and what I found was under application here it was still pointing at hello world instead of memory test. So we go ahead and run this, it reprograms the FPGA and it goes through its checks, and I'll switch over here and we can see GK term, our serial port, and it'll run through everything and check the memory. And while we're waiting for that to load, I can start to talk about the next lab, which is the Tickle and TCL, which that'll be back over in Vivado, and that'll talk about the scripting language and what we can do with that. Alright, this is almost done, 99%. And there we go. So we passed our memory test. So that pops up in GK term. Okay, the next one is the Tickle, and I'll just do a quick demonstration here about what some of this can do. For instance, in our block design. So we do a lot of things in the lab. We learn how to open and close and save projects and export them. But the big thing is down here, this is the Tickle console, and so I can type commands down here like this, print working directory, and this shows where we are right now. I can change directory, so I can see all the different things in here, like avnet, and I can navigate like this, and I'm actually just using my arrow keys and so on to do some of that stuff. Another thing is we can add and remove things in here. So for instance, we added a port, right? A reset port. So I'll grab the command here and I'll just paste it in here. So I'm going to create a board port, and I've got my diagram up here, and I hit enter on this, and that added right here our external port for reset. Okay, so the other thing that you can do if you're not sure what the command is I can come in here, I can delete it, and if I look down here, I can actually get the tickle command for that delete as well. So one thing that they talk about for this is you can use it for source control, because you can actually export your complete design, so everything you've got in your block diagram and all of your configurations for your clocks and peripherals, and it'll generate a tickle script, which I'll show you. I'll show you one here. Here in the navigator, I just pulled this up. So here's a tickle script. This one requires a certain version of Vivado, right? So you can have it do that sort of check and come through, and this shows all your projects and so on, and you can do all sorts of different things. So we export this and we re-import this as a brand new file, and it's able to do that as well. The last thing in Lab 5, we come in and we add our AXI BRAM, and so we come in, we add this data width, we set, and it's showing what ports it's going to generate, and as soon as we do that, we get a flyout up here that's telling us it can do auto routing for us to do all these interconnects, and so on. So once we do all that, then we're able to regenerate our bit stream and export that, and we are good to go, and that takes us through the end of Lab 5.